Hello everyone, welcome back. Today we are going to be doing the chemistry. This is my first video on paper 4, so I'm going to start doing paper 4 theory papers now. So yeah, let's get started. This is the May-June 2023, the version 2 series. This is the latest one, so let's get started. Question number 1. A list of oxide is shown. So A, B, C, D, E to H. This is a very normal question. In this paper 4 in theory, we always have this kind of question. Now this first question is usually just matching the letters. It's all of them are 1 mark questions as you can see. So we just have to actually read them carefully and know what is what. So the letters may be used more than once or not at all. Okay. So state which oxides, A to H, is responsible for acid rain. Now if you look at from the list of oxides that they have given, the acid rain is responsible mainly because of the non-metal part. So basically the acidic part, non-metals are acidic, they form acidic oxides. So this is basically the very basic concept that you have to understand. So here it could be sulfur dioxide. So we could write D here as the answer. Question number 2, which has a giant covalent structure. A giant covalent, remember, is basically a covalent structure that is very giant. So in here we can see that silicon 4 oxide, has a tetrahedral shape, remember, so we can write C. It is also a giant covalent structure. C is a reducing agent in the blast furnace. So you have to know the conditioning reactions that is going on in a blast furnace. So reducing agent, remember, it's basically an agent that reduces other, but itself is oxidized. So this could be carbon monoxide, because carbon monoxide, remember in the blast furnace, will actually reduce the iron 3 oxide, right, to form Fe plus CO2. So we have to choose carbon monoxide. It is a reducing agent. That is something that you have to simply remember. D, which is the main constituent of bauxite. So bauxite is basically an ore of aluminum. You have to know this is an ore of aluminum. So you have to know the aluminum oxide is actually one of its main constituents. So we have to search aluminum oxide, and that is B. So number E, the main impurity in iron ore is basically, as you have guessed, the main impurity in iron ore is also silicon oxide, silicon 4 oxide, SiO2. This is something you should know. Silicon 4 oxide is basically sand, and that is one of the large impurities, so C is the correct answer, which can be reduced by heating with copper. Well, so copper, right, we want to reduce this oxide by heating it with copper. So basically this is a displacement reaction. So basically this metal has to be lower than copper in the reactivity series. So it could be silver oxide, because silver, remember, in the reactivity series, copper is actually higher than silver. So copper is going to replace in silver oxide. So this is going to be G. So that's question 1 done. Let's move on. Question number 2. Fluorine, chlorine, and bromine are group 7 of the periodic table. State the name given to group 7 elements. Well, the name that is given to them are called the halogens. Their name halogens, and that's a name that you have to remember. Explain why the group 7 elements have similar chemical properties. Well, this is because of their outer same number of outer shell electrons. Yeah, so that's basically the reason why they have same chemical properties. So number C is completing the table question. So we have to show the color and state at room temperature of the group 7 elements. So this question is asking you about the trends of the group 7 elements and whether you really understand them or not. Remember, fluorine is at the top of it goes from top to bottom. So fluorine is a gas at room temperature. You have to remember that. Chlorine is also a gas at room temperature. Bromine is a liquid at room temperature. Now chlorine color at room temperature is actually a yellow-green color. It is very similar to fluorine, but it has a very slightly greenish color to chlorine. Now bromine at room temperature is a red-brown liquid. And in some cases, they will like you to add iodine as well. So iodine is actually a black solid at room temperature. So although they haven't asked you the state and color of iodine in this question, but it's very highly likely that when you get asked about this, you are supposed to know. Question number D. Bromine has two naturally occurring isotopes, 79 Br and 81 Br, Br81. State the term given to the numbers 79 and 81 in these isotopes of bromine. So what is the meaning of isotopes? Isotopes are basically same element but different number of neutron, or different number of mass number or nucleon number, whatever you like to say, they all mean the same thing. Okay, mass number and nucleon number means the same thing, but basically the fundamental is that they have different number of neutrons. So we can say that these numbers represent the mass number or the nucleon number, i.e. It basically means the subatomic particles that is in the nucleus is called the nucleon number. Okay, this question is also a completed question to show a number of protons, neutrons, electrons of the ions of protein of bromine. Okay, so the protons, remember, will be the same because they are essentially the same element. The same element, so Br has a proton number of 35. And how do I know this? Well, you can check your periodic table that is given at the end of the exam. So the number of neutrons in here, in this case, will be different because the mass number are different. So remember, the mass number is basically the number of protons plus the number of electrons. So number of protons here is 35, number of Br 79. So what is the number of neutrons? Sorry, proton plus neutron in the mass number or inside the nucleus. It contains proton and neutron. So if you want to know the neutron number, you just subtract 79 from 35. This is basic mathematics, and if you subtract them, you will get an answer of 44. So this goes the same thing. The same principle is used for the bromine 81. So 81 is equal to 35 plus the number of neutrons. So the number of neutrons is 81 minus 35. This gives us an answer of 46. So you can fill that in. Now, the next question is asking you about the electrons. So the electrons in this case is because bromine, here you can see there's no charge. There's no charge over here. But here you can see there is like a minus charge here. -1 charge here. So you can see that this one is a neutral atom and this one is a negative ion. So in other words, it has gained 1 electron. So basically, if a neutral atom is basically proton is equal to the number of electrons. So if we have 35 protons, that would be 35 electrons. In this case, there's an extra 1 electron in Br81. This extra electron will change the electron charge to -1. So it's going to be 36 electrons. This is why it has a -1 charge on bromine. Moving on. Question 3 shows the relative abundance of two naturally occurring isotopes of bromine, 79 and 81. We have to calculate the relative atomic mass of bromine to 1 decimal place. Now to calculate the relative atomic mass, basically, what we have to do is basically multiply these percentages to the mass number. So we can say that 79 multiply 55% plus 81 times 45% And this is going to give us an answer of 7790. I'm just going to divide 100. Now this is going to give us a 79.9. And so the relative atomic mass is 79.9 grams per mole. That's the unit of AR, atomic mass. Right? So we can multiply them like that and then divide this whole thing by 100. Now you're going to get this answer. Moving on to question number E. Chlorine displaces bromine from aqueous potassium bromide, but does not displace fluorine from aqueous sodium fluoride. Now this is because chlorine is less reactive. Chlorine is more reactive than bromine. And fluorine is more reactive than chlorine. So the more reactive one can displace the less reactive one. So that's basically the key concept here. So we have to write a simple equation for the reaction between chlorine and potassium bromide. So basically a chlorine is going to replace the bromine in its compound. So chlorine, remember, is CO2, it is a diatomic molecule. And then we are going to react that with potassium bromide, which is KBr. Now we are going to write arrow sign here. And here, because we know that chlorine is going to displace bromine, it's going to be KCl plus bromine is going to come out as a result of the double displacement reaction. So this is the answer. But is this done? It's not done because it gives us 2 marks, and one of the marks is that you can see that we have not balanced the equation. If we want to balance the equation, we are going to, because we can see that there are 2 chlorine molecules but only 1 chlorine molecule here. So we're going to multiply this by 2. And because they have 2 potassium here, we are going to multiply it by 2 again into the side as well. Now this gives us the final equation for this. Now we have question 2 asks why chlorine does not displace fluorine from aqueous sodium fluoride, and that's because chlorine is less reactive than fluorine, and that is a very basic answer, worth it for 1 mark. Aqueous silver nitrate is colorless solution containing silver ions. Ag, remember, is silver. Describe what is seen when aqueous silver nitrate is added to aqueous sodium chloride. So this is another double displacement reaction, because when you react silver nitrate with sodium chloride, we know that in the reactivity series, sodium is more reactive than silver. So silver is less reactive than sodium, so sodium is going to take place there, and silver is going to take place in sodium. So essentially this is called a double displacement reaction. So basically it's going to form NaNO3, sodium nitrate, and silver chloride. Now remember, silver chloride is going to be seen as a precipitate, a white precipitate, and you have to know your colors as well. You have to remember or memorize the colors of the precipitate of silver salts, or basically you have to know that all chlorides are soluble except silver and lead chloride. So here we can see that a white precipitate is going to form when we add silver nitrate to sodium chloride. So next, the question let us write the ionic equation for the reaction between silver nitrate and aqueous sodium chloride. Now we have to include the state symbols. This gives us 3 marks. So for this full 3 marks, you have to write a balanced chemical equation. You have to make sure that there are state symbols included, and basically the overall reaction is correct. All your formulas should be correct. So basically, this equation is basically the one that I have written before. So it's going to be a double displacement reaction. Silver nitrate, silver is 1 plus, nitrate is 1 minus, so it's going to be AgNO3. I'm sorry, we have to write the ionic equation. So to write the ionic equation, let's write out the whole equation first. So let's see that AgNO3 plus NaCO, this is going to give us AgCO plus NaNO3. Now we can basically change them into the ions. So aqueous, the only one that is solid, which is seen as a white precipitate, is silver chloride. So the aqueous ones will be solid, or will be dissolved into their ions, respective ions. So basically this is going to dissolve into Ag plus NO3 minus plus Na plus Cl minus. This is going to give us AgCl, which is solid, so we cannot convert the solid into ions because ions cannot be separated in the solid state. And the Na plus and nitrate. So we can cancel out the same ions, repeating ions. So Na cancel out, NO3 and NO3 cancel out. Now this gives us an overall equation of Ag plus Cl minus. This gives us AgCl. Now don't forget to put the 6 symbols. Ions are only present in aqueous solution, and silver chloride is solid. So when we write this as the equation, we have to write Ag plus Cl minus aqueous is going to be to form silver chloride solid state. And that will give you will earn 3 marks for just writing this ionic equation. So let's move on. Question number 3. Over 2 million tons of sulfuric acid are manufactured every year. State the name of the process used to manufacture sulfuric acid. Now the process that is used to manufacture sulfuric acid is actually called the contact process. So in the IGCSE level, you only have to learn about 2 processes, one of which is the contact process, another one which is the Haber process, and it's really important to know the reaction conditions for all of these, such as the temperature that's needed for certain reactions, the reducing agents, and all those pretty nitty details, which will definitely help if you want to answer 1-mark questions like these. Okay, moving on. Part of the manufacture of sulfuric acid involves converting sulfur dioxide, SO2, into sulfur trioxide, SO3. Now for this reaction, we actually need a catalyst. But let's see what the question asks. It says, describe 2 methods by which sulfur dioxide is obtained. Well, we can obtain sulfur dioxide by basically burning sulfur ores, right? So if we burn sulfur with oxygen, it's going to produce sulfur dioxide. So one of the methods is to burn sulfur ores. Roasting. So one of the methods is basically burning sulfur in air or oxygen. You can write that as well. The second method is basically burning using sulfur ores. So these sulfur ores could be ZnS, right? It could be PbS. If you heat them with air, it's going to form PbO oxide and sulfur dioxide. So we can roast sulfur ores in air, or you can say with oxygen. And both of these methods are going to produce sulfur dioxide. The conversion of sulfur dioxide to sulfur trioxide is a reversible reaction which can reach equilibrium. State 2 features of an equilibrium. Well, you have to know these things as well. one of the first features of equilibrium is that the rate of forward reaction is equal to the backward reaction. You can also say the inverse reaction. So you can use any alternative wording here, but the same principle or the same concept is that the forward reaction has to equal the backward reaction. And the second mark, or the second feature for equilibrium, is that the concentration of reactants and products are constant. In other words, no more reactant is made, right? No more reactant is made than the products, and no more products is made than the reactants. So basically, the concentration of reactants and products are constant. Now the keyword here is constant, and for the first feature, the keyword is forward reaction is equal to the backward reaction. Now this will give you an easy 2 marks for this question. Question number 3. This is a question right to basically the reaction conditions. You have to know them by heart. So remember to learn the Haber process as well. And it's really easy to remember because Haber process and the contact process is very similar. So the temperature used here is going to be 450 degrees Celsius, and that is in the Haber process you will also use 450 degrees Celsius. For the temperature here, we are going to use 200 kilopascal, while in the Haber process we are going to use 20,000 kilopascal. For the catalyst, we are going to use vanadium oxide, vanadium 5 oxide, and for the Haber process, we are going to use iron catalyst. So you can see similarities here. The temperature basically is the same, and the pressure is basically just double the amount of the contact process. So in some cases they will give you in kilopascals, in other cases they'll give you in atmospheres or ATM, and you'll have to know the pressure in ATM as well. For the contact process, we are going to use an ATM of 2 ATM atmospheric pressure, and for the Haber process we are going to use atmospheric pressure of 200 ATM, right? So basically you have to know those, or you could just remember that one atmospheric pressure is equal to 1.01 times 10 to the power 5 pascals, and then you can use this formula to actually just work out the pressure in kilopascal. So it's really helpful once again to remember these conditions in the exam, so you can basically write these things down really quickly and waste no further time. Okay, moving on to question number 4. Complete the table, okay, to show the effect when, okay, so this is equilibrium question. So we are given the equilibrium equation right here. We are given that the forward reaction is exothermic, so we can automatically say that the backward reaction is endothermic. Now we have to use the word increase, decrease, or no change at all. So if we increase the temperature, remember when the temperature is increased, it favors the endothermic reaction. When the temperature is decreased, it favors the exothermic reaction. So when the temperature decreases, it will favor the backward reaction, so the rate of the forward reaction is going to go backwards. Okay, so the effect of decreasing the temperature on the concentration of SO3 at equilibrium, it will increase. Well, why is it like this. Well, if the temperature decreases, it favors the exothermic reaction, which is the forward reaction. So more SO3 is going to be produced when the temperature is really low. The next change is the pressure change. If we increase the pressure, the rate of the forward reaction is going to increase. Now why, you may ask? Well, this is because pressure does not work like temperature. Pressure works like this. Pressure will always go from the highest number of mole or molecules to the side with low number of moles. This is when you apply high pressure. But for low pressure, at low pressure, it will go from low to high moles of substance or moles of something, blah blah blah. So here we can see that I'm going to use a different color. So you can see that here we have 2 moles of sulfur dioxide and 1 mole of oxygen. Now this is going to produce 2 moles of sulfur trioxide. So there's a total of 3 moles in the left hand side and 2 moles in the right hand side. So you can see when pressure increases, it will go from highest number of moles to the lower part of the moles, lower number of moles. So the reaction will definitely increase. Okay, so how about the effect of concentration? The effect of concentration will definitely increase because the effect of forward reaction will increase, therefore producing more concentration or more product of SO3 at equilibrium. Okay, no catalyst. What will happen when there is no catalyst? Well, the rate of the forward reaction will decrease because when there is no catalyst, the rate of reaction is going to be really slow because the activation energy is really high. But the catalyst does not have concentration of sulfur trioxide. It does not increase the product or the reactants in any way. In other words, it does not interfere with the reaction. So this is going to be no change. Question number 5. Explain in terms of collision theory why reducing the temperature decreases the rate of forward reaction. This question is 3 marks question and 3 marker, so you have to answer 3 main points. So it is asking you the collision theory, why reducing the temperature decreases the rate of forward reaction. Well, as I've said before, when you decrease the temperature, when temperature is decreased, the kinetic energy, or the Ke, of particles decreases. If the kinetic energy of particle decreases, the frequency of collisions between particles will also decrease. So this means that a lower percentage of particles have energy greater or equal to the activation energy. Essentially is that the frequency of the collision of the particles decreases, so little particles, or you can say little or low percentage. I prefer using the word little particles have, or less particles, you can use less particles, have less energy greater than or equal to the activation energy. This is why reducing temperature will increase the change. Okay. Number C. Sulfuric acid contains SO2 minus ions. The oxidation of oxygen atoms in SO4 minus ions is -2. Determine the oxidation number of sulfur atoms in SO4 2 minus ions, show your working. Now this is really easy if you know the rules of oxidation. So we are given that the oxidation number of oxygen is -2, and we can see that SO4 2 minus, the total when you add the oxidation number is going to equal to the charge of the compound, which is going to be -2. So sulfur, we don't know sulfur, so we can write sulfur plus oxygen. We are given oxygen is -2, and then this oxygen is, there are 4 oxygen molecules, 4 oxygen atoms, right? So we are going to multiply it by 4. This is equal to -2. So we are going to write the equation like this. So S is going to plus -8 is equal to -2. So S is equal to, right, if we move the 8 to the other side, it's going to be -2 plus 8. Now this is going to give us 6. So the oxidation number of sulfur is 6. Question number 4. Solid sodium hydroxide is a base which dissolves to form an aqueous solution, NaOH. State what is meant by the term base. So a base, you have to write its scientific meaning. It is simply a proton acceptor. And alternatively, if they ask you what is meant by the term acid, you have to say that it is a proton donor. In this way, you can guarantee the mark of 1 mark. So, number B, state the term given to the base which dissolves to form an aqueous solution. Now, this is an alkali. Remember that bases and alkalis are not the same. All alkalis are bases, right? But not all bases are alkali. In other words, alkali is basically a subset. Alkali is a subset of the base. It's basically all alkalis are base, but not all bases are alkali. And the bases that can be dissolved to form solution is called alkali. And this is a definition that you have to remember. So we have to state the color of thymophthalate in sodium hydroxide. Thymophthalate is basically an indicator. So in acid, it actually turns blue. In acid, it is colorless. In alkali, it is blue. Previously, the Cambridge, before they changed the syllabus, they used phenolphthalein, which is basically the same in acid, but in alkali, it would turn pink in phenolphthalein. But in this year, they have started using thymophthalate, so you have to say that the color is blue in alkali. Number D, we have to complete the word equation for the reaction of sodium hydroxide with ammonium chloride. Ammonium chloride has the formula NH4Cl. NH4 is plus, Cl is minus. This gives us a formula of NH4Cl. So this is asking for a word equation, so you don't have to luckily balance it out or write any state symbols. So when we react a sodium hydroxide with an ammonium salt, you will always get ammonia as one of its product. So we can write ammonia as one of its product. You will get water as one of its product, and you will get, because the sodium is displacing ammonium from its salt, it's going to form sodium chloride. So the general equation is like this. You're going to form a salt, a metal salt, plus water, plus ammonia. Ammonia will always be produced if you add sodium hydroxide to an ammonium salt. And this is your 3-mark questions. Very easy questions. Okay, next question. Some metal oxides react with sodium hydroxide. State the term given to metal oxide which react with bases such as sodium hydroxide. Now remember, metal oxide are basic, but there is an exception that some of the metal oxides are actually can react with bases and also acids. Now these oxides are given a special term called amphoteric oxide. So they are called amphoteric oxides. Basically they react with both bases and acid. And these are called amphoteric oxide. Now they are letting us give us an example. So whenever you hear the word amphoteric oxide, you can always give two of the examples, which is the aluminum oxide. You can also give zinc oxide. Make sure if you write in the formula form, you have to make sure your formula is correct, or you can also give it as aluminum oxide in the word form. It does not really matter. So yeah. F. Ethanoic acid is a weak acid. Complete the dot and cross diagram of a molecule of ethanoic acid. Okay, so we know that carbon has a valency of 4. In other words, it has 4 outer electrons, so it can accept 4 more electrons. We know that hydrogen has a valency of 1. Basically it has 1 outer electrons. It needs two outer electrons to basically become stable. And oxygen has a valency of -2. In other words, it has 6 outer electrons. It needs 2 electrons to turn into 8 electrons so that it can achieve noble gas configuration. So this is basically the basics that we work with. So they have drawn us the inner shells already. We have to draw the outer shells. And now usually it would be nice for the examiner if you write a key for it. So for example, carbon, we are going to represent it by the circle. For H, we are going to represent it with the cross, right? For the oxygen, we are going to represent it with an O, a hollow O. So you have to write the key like this. It's not necessary, but however, it is better for you as well to see which one is which. So here we see that carbon has 4. It's going to have 4 electrons, so it's going to bond with 4 outer electrons. And hydrogen has 1, so it's going to bond with carbon. So hydrogen, all of the hydrogen is now stable. Now, the carbon atom here still needs to be stable, so we are going to put this. So it's going to be 8 around carbon atom, so they are already stable. Okay, and for the next one, we can see that carbon and oxygen, right? This carbon and oxygen is basically a single bond, right? So there's a single bond and also a double bond, and I'll tell you why later. Because if you write it down in the Slate formula, it's going to look like this. So there's going to be one double bond and another single bond between carbon and oxygen. So it's really important to know that a double bond exists and a single bond exists as well. So if we put a double bond in here, there's going to be 4 more oxygen electrons that's going to be left, and we give 1 electron, so there's going to be 4 more here as well, because this oxygen is also going to be bonded with hydrogen. So 1 hydrogen, 1 oxygen, so it's going to be balanced. Now always recheck your drawings. Make sure you don't miss the outer electrons like these ones. Make sure you don't miss the outer electrons like these ones. Okay, moving on. we have to suggest the pH of the dilute ethanoic acid. Remember, ethanoic acid is a really weak acid. It is found in vinegar. So the pH has to be really high, not really high, but it has to be moderately high. So this could be a pH of 5 per se, right? Anything, the pH could be anything less than 7, right? It could be less than 7. It could be less than 7, but it has to be more than 3. So the pH could be anywhere between the range of 3 and 7. Now complete the simple equation to show the dissociation of ethanoic acid. Now dissociation is basically a fancy term of dissolving. So it basically means the dissolving of ions in this case. Now this is we have to use the sign, the reversible sign, because the dissociation of ethanoic acid is not 100%. In reality, it is only 1% that is dissociating. So only 1% of that is going to be turned into ions in solution. So it is basically a very low amount. So we can say that is also the reason why it is a weak acid. So in case they ask you like that. So CH3COOCH, this is going to give us a negative ion and a positive ion. So it's going to be CH3COO. This is going to be an ethanoate ion and a hydrogen, or the hydrogen ion. Okay, so it's going to give us both of these. So make sure the charges are correct. Hydrogen is always positive. In most cases, right, hydrogen is always positive. And then the COOC, the ester group, right, there's an ester group there, is going to form a negative. Now this is going to be an ethanoate ion, and hydrogen is going to be a positive ion, or a cation. So write the ionic equation for a reaction when an acid neutralizes a soluble base. Now basically when an acid and a base react, right, when an acid and base react, acid plus base, it is going to form salt and water as its waste product. Now, because water is always going to be formed, we can write the ionic equation as H plus OH minus. This is going to give us H2O. So we are going to write this for the ionic equation. So it is going to be H plus OH minus. This is going to give us H2O. Now if you're wondering why we don't write the other acid, which is like, for example, H2SO4, sulfuric acid, H plus, and SO4 2 minus. Now you might be wondering why we don't write the sulfate ions. Well, this is because when the acid react with a base, a double displacement reaction is going to happen. So a base could be NaOH, right? The Na plus OH minus. So this Na is going to take place in hydrogen, and hydrogen is going to react with the hydroxide reaction. So it's going to displace them, and it's going to form NaSO4, which is Na plus and SO4 minus, right? So there are both Na plus on both sides, so we can cancel them out. In other words, Na and SO4 are spectator ions. Because they can be cancelled out, they are spectator ions. And therefore, the overall reaction of any neutralization reaction is always producing water. So it's going to be H plus OH minus is equal to H2O. In a titration, 25 centimeter cubes of 0.08 moles per dm cube of potassium hydroxide is neutralized by 20 cm cube of the sulfuric acid, H2SO4. Now we have to calculate the concentration of sulfuric acid in grams per dm cube and use the following steps. We just have to follow the instructions. It's really easy. You have to remember the mole formula. So let's get started. So find the number of moles of potassium hydroxide used. So the number of moles, remember mole is equal to mass over molar mass, but in this case we are not going to use that because in this case we are going to use because we have given we have been given the concentration, we have been given the volume. So remember, concentration is equal to mole by volume, right? So when we want to find mole is equal to concentration times volume. So the concentration here is 0.008 mole per dm cube, and the volume here is going to be 25 cm cube. Remember, 25 cm cube, because there's a dm cube here, you cannot write with different units. You have to either change it to centimeter cube or dm cube. So 1 dm cube is basically equals to 1000 cm cube, so we can change it to dm cubes. So 25 times 10 to the power minus 3 dm cube. So we can then cancel the dm cube out, and we are going to get the answer of approximately, we're going to get an answer of 0.002 moles, right? So let me solve it right here. 0.008 multiply 25 times 10 to the power minus 3. This gives us an answer of 0.04. It's going to give us an answer of 0.0002. Yep, so 0.0002 moles is going to be formed. So we have to determine the moles of sulfuric acid that is going to be formed, which reacts with this. I'm sorry, I think I did something wrong with the calculation, so I'm sorry. So actually I copied the question wrong. It is going to be 0.080 moles. So when you multiply them together, you are going to get 0.002 moles. I'm sorry, my bad. 0.02 moles. Okay, so we have to determine the moles of sulfuric acid that react with potassium hydroxide. What we are given, we have to look at the molar ratio, because KOH, we are going to set up a molar ratio. KOH ratio H2SO4. Now the ratio is given 2:1 from the equation above, 2:1. So if there is 0.002 moles, now how many of sulfuric acid will react? Well, this is very basic. It's going to be reacting with 0.01 mole. Now to calculate the concentration in mole per dm cube, we can use the formula concentration is equal to mole per volume. So mole is 0.001. The volume here is given 20 cm cube. So 20 cm cube, we have to change it to dm cube because the answer requires us in dm cube. So 20 times 10 to the power minus 3. Now this is going to give us an answer of 0.05 moles per dm cube. Now we have to calculate the concentration of H2SO4 in grams per dm cube. Remember, this is the very last step. So if you want to convert mole per dm cube to grams per dm cube, you have to multiply it by the MR. Right, so the MR is basically the MR of H2SO4. The MR of H2SO4 is basically, look at the mass in the periodic table that's given. Now you will see that H2SO4 has an MR of 98 grams per mole. So mole per dm cube multiply the MR, which is grams per mole. Now you can see that the moles and moles cancel out. Now this gives us grams per dm cube. And this is why we have to multiply it by MR. So basically use the previous mole per dm cube, 0.05 mole per dm cube, is going to be multiplied with 98 grams per mole. Now this gives us an answer of approximately 4.90 grams per dm cube. And this is how you work out the answer here. 5. Propane and propene both react with chlorine. When a molecule of propane, CH3H8, reacts with chlorine in the presence of ultraviolet, one atom of hydrogen is replaced by one atom of chlorine. State the term given to the reaction in which one atom of alkane is replaced by another atom. So basically this is being replaced or substituted. So we call this actually a substitution reaction. And this is only occur in alkanes. This only occurs in alkanes. So remember that. So state the purpose of UV light in this reaction. Well, the UV light here is basically to provide the activation energy. Because without activation energy, you are not going to be able to kickstart, or you're not going to be able to start any chemical reaction. So the purpose of UV light here is to provide the activation energy. You can write it in EA, or you can write activation energy ... right? So state the term given to any reaction which requires ultraviolet. Now, because this violet is basically still light, we call this type of reaction a photochemical reaction. Photo meaning light, chemical as in chemical reaction. So we call this a photochemical reaction. Next, write the simple equation for the reaction between propane and chlorine. So propane, remember, is C3H8. Right, it has a general formula CnH2n plus 2. So if n is equal to 3, H is going to be 2 times 3, which is 6. 6 plus 2 is 8, so C3H8. This is the formula of propane. Chlorine is going to be diatomic. Remember to always add the 2, it's not monoatomic. And then it's going to be C3H7Cl plus a side product, which is hydrogen chloride, HCl. Because remember, one of the hydrogen is going out, one of the chlorine is going inside the propane molecule. This is why it's called a substitution reaction. So the chlorine in the chlorine molecule is going to go in, and the one of the H from the propane molecule is going to go in place of the chlorine. This is why it's called a substitution reaction. So the equation should be C3H8 plus Cl2. This is going to give us C3H7Cl plus HCl. Okay, a molecule of propene, which is unsaturated, will react with chlorine at room temperature. State why propene is an unsaturated molecule. It is an alkene. Why is it an unsaturated molecule? Well, this is because it has a double bond. Basically, i.e., you can write it CC double bond. It has carbon-carbon. It has carbon-carbon double bond. You can write it like that. Or you can just write it that it has a carbon-carbon bond, which is not a single bond. It is also fine, whatever you want. There's one mark question. Give the structural formula for the product of this reaction. So a propene, C3H6, is going to react with chlorine. Now in this case, it is called an addition reaction because you are reacting with an alkene. An alkene will not undergo substitution. Instead, the double bond here, in this case, the propene is going to open the double bonds, and the Cl is going to come in one of these carbon atoms. So you can write this as CH3, CH, Cl, CH2, Cl. right? So the double bond could be in the first one or in the second one, at whatever you like. So just try to draw out the structure and try to write it like this. So this is going to be CH3, CH, Cl, CH2, and Cl. So you're going to write it like that. Okay, question number C. Propene undergoes addition reaction with steam. There are two possible products, A and B. Draw the display formula and name each product. The display formula of product A, okay, propene undergoes reaction with steam. Steam is basically water. I hope you know that by now. So we are going to draw propene react with steam. We are going to draw the formula of the product. So basically propene, remember, is going to be C3H6. Remember, propene looks something like this, right? It's going to react with steam. Propene is going to react with steam, which is water molecule, which is HOH. So we have to write what this forms. Well, when an alkane and water is going to form an alcohol. It's going to form an alcohol. In this case, it's going to form a propanol. Right, so we are going to draw a formula of propanol. So we can write C H H H C H H. There's going to be 3 carbons because it is prop, meaning 3. And we are going to draw an OH here at the end. So we can say that this is, because the OH group is attached to the first carbon atom, we can say that this is a propane 1-ol. Now you might be wondering, why do they give another product B? Well, in this product B is actually just, it's basically just an isomer of propanol, because propanol can actually form 2 different ways, where the hydroxide ion, the hydroxyl group can attach to the first carbon atom. It can attach to the first carbon atom, or it can attach to the second carbon atom. So how will this look like? Well, let's draw it. This will look something like this: CH3 C, right? There's going to be an OH here, there's going to be H here, and there's going to be CH3. So it's going to look something like this. The OH group here is going to be attached to the second carbon atom. So we can call this propan2-ol. This ol is added for the alcohol, right? So it is really basic and easy to understand. Question number 6. Carboxylic acids can be converted to esters. Name the ester form when butanoic acid reacts with ethanol. Right, butanoic acid is going, remember the acid part will always form butanoate. Right, it's going to turn into a minus ion. And ethanol is going to be an ethyl group. We just add the YL at the end. So basically we are going to write ethyl butanoate. Remember, the acid will always turn into a butane, and the ending OIC you have to change it to OATE. And for ethanol, you have to change this NOL to ETH-YL, because it is an alkyl group. CH3, CH2 is an alkyl, is ethyl, or an alkyl group. So we have to identify the other product formed in this reaction. The other product that will be formed in this reaction is going to be water. Water is a waste product whenever you convert esters, whenever esters are formed. Remember, ester is basically acid, carboxylic acid plus alcohol. You're going to form esters and water as a waste product, so you have to write water. Deduce the empirical formula of the ester form. So the empirical formula of the ester is going to be something like this. So we basically have to draw this out. So it's going to be something like this. Okay. So it's going to be C, right? C, butanoic acid. It's going to form the negative part. So if we draw them, we can draw them like this. And we can add the ethyl group. So I'm not going to write the H here. Okay, I'm not going to write the H of the H atoms. But here, I just want you to notice that there is ester linkage here. This is why it's called an ester. And this part right here is the carboxylic acid part. And this part right here is the alcohol part. So we can write the empirical formula, just count down the number of carbons, the number of hydrogens, the number of oxygens, always draw them out. We can see that there's going to be 1, 2, 3, 4, 5, 6, there's 6 carbon atoms. There's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's going to be 12 hydrogen atoms and 2 oxygen. Now, if we want to write the empirical formula, we have to divide it all into its simplest whole number ratio. So this is going to be C3H6O. So the formula is going to be C3H6O. Okay, for D, PET is a polyester. Part of the structure of PET is shown. We have to draw a 1 repeat unit of this polymer. A repeat unit is basically a unit that is going to get repeated. So this is a polyester. Remember, polyester is formed from an acid and diol, right? An acid or an alcohol. So you can see that there's one is shaded and one is not shaded. So the whole part of the molecule, we have to get the acid part and also the diol part. So we have to get from this end to this end, right? So we can draw the ring around here. Or if you still do not understand, let me explain it. Because acid, remember acid, right? We have the acid group COOOH. This shaded part is COOH, and this one is going to react with the unshaded, which is the alcohol group or the diol group. So here, basically the OH and H is going to go out. OH and H is going to go out. Now this is going to give us COO, CO here, CO here, and an O and an O here. So this is going to be the correct structure, the ring that you have to draw. State the type of polymerization used in making PTE. PTE is a polyester, right? PET is a polyester. So this polyester is going to form a waste product, which is water. If they form another molecule, a small molecule that's being eliminated or that's being removed, we call this condensation polymerization. And remember that there are 2 types of polymerization. There's the condensation polymerization, right? And there's the addition polymerization, which produces no water molecule, no waste product. So we can say that the condensation polymerization is the correct option. So we have reached to the end of this video. The periodic table is given here at the end. But make sure to use it to full use. Anyways, I hope you understand everything I have explained in this video. Thank you for watching. And if you have any questions, leave them down in the comments below. I will be more than happy to elaborate further if you have any doubts. If you don't have any doubts, please leave this a like and comment if this helped you, or if you want me to do other versions as well. Thank you for watching these videos, always supporting me. These videos takes a very long time to make. So have a good day. Until I see you next time.